everyone, I'm Ibrahim and I'm from Global Matriculation College. So today I will be presenting about chapter 5.3 power. So we all know that the SI unit for power is joules over second, or we can call it as watt, W-A-T-T. So we all know that there's the two formula for power. So the first formula is power average equals to delta work over delta time. So we know that delta is difference from initial work done and the final work done. And W is work and T is time taken when the work is done. So for the second formula, we know that delta E or delta energy over delta time. So we know E is as an energy and T is time taken. So the first formula we can use for the first diagram as a situation. So we know that when the boy or girl kicks a ball, we know that the energy transferred from the leg, her or his leg, will be used as work done, and the time or the moment of contact or how long it contact the contact between leg and ball will be considered as time taken. So when we put the both of that into the equation, we will get the power for the first equation. And for the second situation, we are looking at the kettle boiling water. So we can use that E is energy used by kettle to boil the water to its boiling point, and T is time taken for the water to boil.
Is lifted 200 meters above the ground in 5 minutes. How much work is required to lift it 200 meters into the air? So the work required to lift something against gravity is mg delta h. So the mass of the crate is 20 kilograms. The gravitational acceleration is 9.8, and it's being lifted to a height of 200 meters. So if you multiply these three numbers, you should get 39,200 joules. So that's how much energy is needed to lift up this object. Now, how much power is exerted on this crate? Now, the crate is lifted 200 meters in 5 minutes. So we need to convert 5 minutes to seconds. Each minute is equivalent to 60 seconds. So 5 times 60 is 300. So to calculate the power, it's going to be the work divided by the time. So it's 39,200 joules divided by 300 seconds. So the average power is about 130.7 joules per second, or watts. And so this is the answer. Number 2, how long will it take a 2.5 kilowatt motor to lift an 80 kilogram block 30 meters high? So here's the block. It's 80 kilograms. And we want to lift it with a rope using a motor. So we're going to apply an upward tension force to lift it. So how can we calculate the time? Well, first, let's calculate the work required to lift up the object 30 meters high. So we're going to use the same formula, mg delta h. So it's going to be 80 kilograms times 9.8 times the height of 30 meters. And so that's going to be 23,520 joules. So that's the work required. Now we know that power is work divided by time. So let's solve for t. Let's multiply both sides by t. And so work is equal to power multiplied by time. Now let's divide both sides by power. So the time required is equal to the work divided by the power. So the work is 23,520 joules. And the power is 2.5 kilowatts. 1 kilowatt is 1,000 watts, so 2.5 kilowatts is 2500 watts. So therefore, it's going to take 9.4 seconds for the motor to lift a block 30 meters high.
My name is Effendi from Matriculation College. I will take over this second part of video for the subtopic 5.3 power. As for my partner Ibrahim mentioned before, power average equals to delta work over delta time. Whenever work done, energy is being transferred from one body to another. For example, work is done when the foot is kick the ball, and time is taken when the foot is touch the ball. Hence, we also can say power is rate, which is energy is transformed. As we know, power is kind of unit. And secondly, for practical purposes, a larger unit of what is horsepower. 1 horsepower equals to 746 watt. Okay. Thank you for watching this video. I hope this video is useful for you. Thank you.